In order to transport seedlings from the nursery to the market, a manufacturing engineer designs an open box with a square bottom and 4 sides of equal height. For the most efficient fit, the volume of the box must be 900 cubic inches and use 465 square inches of cardboard. Find the dimensions of the box. So there's a lot of information here. We need to break this apart. So let's start with a picture. What do we know about the particular features of this box? So it says that it's an open box, which means that it has no lid, and it has a square bottom, which would be a square base, and then 4 sides of equal height. So let me do my best to try to draw this. So we're saying it's an open box with no lid, and the base is going to be a square, essentially. So this base here, this base is going to be a square, so I'm going to put little tick marks around the base to indicate that all 4 sides are the same length. The base is a square. However, we're recognizing that we have no lid on this box. No lid. So it's important to make note that we do not know that this is a cube. And on occasion, I'll have some students draw the diagram and make the mistake and think automatically that the figure is going to be a cube. But there's nothing in the problem that says that the height is the same as the length of the base. So you do need to really be careful and don't assume that it's going to be a cube. So that's why I specifically like to draw a box that's definitely not a cube, so I don't make that assumption. Now let's identify other information that we know in the problem. It says for the most efficient fit, we know the volume is 900 cubic inches. So I'm going to use V for volume. So I know my volume is going to be 900 cubic inches. And then the next part tells me that it must use 465 square inches of cardboard. So look at the units here. I sometimes jokingly say we want to cheat off of the units. If the units are measured in square inches, then that tells us that this is going to be an area. So if we're using up 465 square inches of cardboard, then we're talking about the surface area of this shape. So I'm going to use SA to represent surface area. And what surface area means, remember, is you're adding up the area of all of the faces, all of the sides of this figure. So in this case, we would have 4 rectangles that make up the sides, and then we would have 1 square that makes up the base. And when we add all of those areas together, we should get 465. And what we're asked to find the dimensions of the box. So what we don't know in this case is we don't know the length of the base. So that's one of our unknowns. So I'm going to go ahead and use X to represent the length of the base. I do know the base is a square though, so I can go ahead and mark all 4 sides, if you wanted to, of the base, which is a square. They would all be marked as X. And then I don't know the height of this box. And if you want to use H for height, or if you prefer to use Y, since this is a vertical measurement, that would be fine too, but the height is unknown. So my dimensions right now are X by H. So let's look at the first equation. The first equation said that the volume was equal to 900. So how do we compute the volume of a box like this? The official geometrical term here is this is a rectangular prism. And to compute the volume, you're going to multiply the length times the width times the height. So the volume of a box, such as this one, is length times width times height. I know our volume is 900, and then the way we have our box labeled, the length is X, the width is X, and the height is H. So this is going to simplify to give us the equation 900 is equal to X squared, times H. So this is one of our equations. However, this equation has 2 unknowns, which means I need to write a second equation to relate these variables X and H. Here's where we have to use the surface area. Now, there isn't a special formula for surface area. Remember, again, we're just looking to add up the area of all of the individual faces or the sides of the box. So for example, let me start with the right-hand side, this one here that I'm outlining in blue. This is a rectangle, and it is a rectangle that has a base of X and a height of H. So the area of that rectangle would be X times H. However, the left-hand side is also the same rectangle with a base of x and a height of h. So the area of the left side is also going to be x times h. So the right and the left are both areas of x times h. Now let's look at the front of this box. The front I'm outlining in green. This is also a rectangle, and this is a rectangle with a base of x and a height of h. So it also has an area of x times h. And so will the back side of the box. It will also have a rectangle with an area of x times h. So far I have added up all of the areas of the four sides. So therefore all that I have left to add would be the area of the base. And the base, remember down here, the base is a square. So I'm drawing that in red, and the area of this square would be x times x, which would be x squared. So adding all of these together, this will be the total surface area, and the total surface area was said to be 465. So if we combine like terms, we have xh added together 4 times, so that would be 465 is equal to 4xh plus x squared. 465 equals 4xh plus x squared. So this is my second equation in my system of equations. So let me go ahead and show how this would be written with a curly bracket. Our first equation is x squared times h equals 900. And then my second equation, I'm going to just reorder it. I'm going to write the x squared term first, which would be x squared plus 4xh is equal to 465. This is ultimately the system of equations that we are now trying to solve. So we're going to either use substitution or elimination. And in this case, substitution is going to be easiest because we are going to be able to solve for h in my top equation. And I'm going to divide both sides by x squared. So we're solving for h by dividing by x squared. So h is equal to 900 divided by x squared. And then I'm going to use substitution and substitute that h quantity into my second equation, which will give me x squared plus 4x times what used to be h, but we're substituting in the expression 900 divided by x squared, and that's equal to 465. And now we have an equation that is entirely in terms of x. So let's go ahead and simplify. We have x that will divide out with the x squared. Remember, if you need to remind yourself that we really have 4x over 1, so you don't make a computation mistake there, then go ahead and put your 1 in the denominator. So then that leaves me with 4 times 900, which will be 3600, all divided by x is equal to 465. Now I need to eliminate the division. I have 3,600 divided by x, so I can undo that division by multiplying by x. So I'm going to multiply everything on the left-hand side of my equation and everything on the right side of my equation. I'll multiply by x. So when I distribute, x times x squared will give me x cubed. When I distribute the x here, this is where the x's are going to divide out. So we'd just be left with a positive 3,600. And then that will be equal to 465x. So we are successful so far in getting rid of the fractions, essentially. Now, what remains here is a new equation, and this one happens to be a cubic equation because we have x raised to the third power. So this is a polynomial equation, but specifically it's cubic because it's degree 3. So we want to go ahead and set this equal to 0. So I will subtract the 465x. So x cubed minus 465x plus 3,600 will be equal to 0. And now our job is to kind of review, how do we solve polynomial equations like this one? So first, you would start by trying to factor. However, there isn't a greatest common factor for this polynomial. So then we really have to dig way far back to something you may have studied earlier in the semester, which is called the rational zeros theorem. So that's where we look at the factors of the constant term, which is 3,600, divided by all the factors of the leading coefficient, which in this case is 1, and then we know those are the possible rational zeros. And as you can imagine, there's going to be a whole slew of factors for 3,600. So at this point, this is where I would go to my graphing calculator. So I want you to pause the video, get your graphing calculator out, and why don't you go ahead and graph this function that we have on the left. So I want you to be putting y equals x cubed minus 465x plus 3,600. I want you to be putting that into your calculator, and we'll utilize our technology for right now to help us find one of our zeros. So I'm going to go to a new page here and bring in Desmos, since I don't have a graphing calculator on here. And I'm going to graph the function in Desmos. I'm hoping right now that you're graphing it on your graphing calculators. So x cubed minus 465x plus 3,600. And remember, we expect to have a cubic shape. So when you look at your standard viewing window, you might just see a little bit of the right-hand side of the graph, but you're going to need to adjust your window considerably to see the rest of the graph. On Desmos, it's easy to just kind of pinch and zoom. On your graphing calculators, you would need to use your window feature and adjust your window. So you can see on mine here, I see the cubic shape, but realizing, oh my goodness, this graph is going to go really, really, really far up high, which makes sense because of my y-intercept of 3,600. So if I was interested in seeing the entire graph, I would have to adjust my window considerably. But truthfully, I'm only interested in looking for the zeros, which are the x-intercepts in this case. So you can play around with your window if you want. I'm just going to use Desmos to kind of really zoom in here on my zeros. And it looks like I have an x-intercept something between 9 and 10, but that's not a nice exact value. It may be a decimal. But it does look like my other x-intercept on the far right looks to be positive 15. So I'm going to go ahead and use 15 as my starting place, and I'm going to try positive 15 for my synthetic division.
So we'll go ahead and use positive 15 for our synthetic division. And remember that the coefficients are what we're going to use in the top row of our synthetic division, but we do need to be aware that we are missing a term here between the x cubed term. And oops, looks like I forgot to write my x. Sorry about that. So that was x cubed minus 465x plus 3,600. So my coefficients will be a 1 for the x cubed term, 0 for the x squared term that's missing, negative 465 for the x term, and then 3,600, which is my constant. So we'll drop the first value down, multiply 1 times 15, add 0 plus 15, multiply 15 times 15, which will be positive 225, add negative 465 plus 225, which will be a negative 240, and then multiply negative 240 by 15, which is going to give us a negative 3,600. Thank goodness, because that tells me that my remainder is 0. So this confirms that 15 is one of my solutions to this equation. 15 is going to be one of my zeros. So now what remains is a 1, 15, and a negative 240, which represents a 1x squared plus a 15x minus 240. We'll set this equal to 0, and now we're searching for 2 more answers. Remember, we're not going to quit because this was a cubic equation that we were solving, so we know there needs to be a total of 3 answers. They may not all be real numbers, but we need to have 3 solutions altogether. So now I'm going to try to solve this quadratic equation. And I certainly could try to factor, but because of the size of the constant of negative 240, I'm not going to bother with factoring. I'm just going to go straight to my quadratic formula. So x is equal to the opposite of the b value, which will be a negative 15 plus or minus the square root of the b value squared, 15 squared, minus 4 times a times c, which will be minus 4 times 1 times negative 240, all divided by 2 times a, which will be 2 times 1. From here, I want you to go ahead and grab your calculators, and let's go ahead and compute this entire expression. I'm hoping that you don't put it in individual pieces, but you actually use your graphing calculator to input this entire expression exactly the way we have it written here. So this looks to give us two different values, and they're both decimals. So we're just going to approximate our answers here. The positive value looks to be positive 9.71, and then we get a negative value, which is a negative 24.71. Now, looking back at your original diagram, remember x was the length of the base. So a negative value doesn't make sense in this case, so we're going to automatically disregard the negative value, and it looks like we're getting a second value that is an answer for x. So right now, we got that 15 worked earlier, so we have x is equal to 15 as one of our values, and then x is approximately 9.71 for a second possible x value. Now let's look back at our original diagram. We are being asked to find the dimensions of the box. So we need to find the length, the width, and the height. Right now we have the possible x values, so we need to find the h values, the height. And remember, this first equation in our system of equations, which was x squared times h equals 900, we had already solved for h earlier on when we did our substitution. So h was equal to 900 divided by x squared. So let's go ahead and use this equation and substitute in our x values so we can solve for h. So h will equal 900 divided by 15 squared. So right now I'm substituting in an x value of 15, and that's going to give me a height of 4. So that means I have dimensions of 15, and you'll have to look back at your units. Remember that the volume was measured in 900 cubic inches and the surface area was 465 square inches. So these dimensions are going to be measured in inches. So that would be 15 inches by 15 inches because the base was a square. So x was 15, and when x is 15, the height was 4. So that would be a 4-inch height. So here is one set of dimensions that will certainly work. A 15 by 15 by 4-inch box will satisfy these requirements. But it turns out, this is kind of a special case, we also have another value that's going to work. We need to substitute in our value of 9.71. Now, if you really wanted to be super accurate, then you would actually want to store in that value. Since it wasn't exactly 9.71, I did round this number, but I'm okay with you substituting in 9.71 in this case. So 900 divided by 9.71 squared, and that's going to give us a value of approximately 9.55. So the height is 9.55 inches when x is 9.71. And that's going to give us a second set of dimensions, that the box could also be 9.71 inches by 9.71 inches by a height of 9.55 inches. And these dimensions would also satisfy the original requirements of the volume being 900 and the surface area being 465. So it turns out we end up getting two possible solutions, two possible sets of dimensions in this particular case.